Quantum and classical mechanics seems two completely different subjects with no connection between them. But that's not true. Quantum and classical mechanics are very deeply related, which is what I am going to show you in this video. This equation right here, known as the Schrödinger's equation, tells us how the wave function psi is going to evolve with time. Wave function in general has no meaning to itself, but its modulus squared gives us the probability amplitude for finding the particle in an infinitesimally small region. Wave function, in general, is a complex number, and thus it can be written in its polar form. I right here represents the amplitude of the wave function, and S by h bar represents the phase of wave function. I won't be telling you now what does S represents, but it will be clear within a few moments. Now, we need to compute the time derivative and Laplacian of the trial wave function. Upon doing so, we are going to end up with this equations right here. Now, we need to substitute these time derivative and Laplacian of the wave function back into our Schrödinger's equation. Upon doing so, we are going to end up with this final equation right here. Now comes the most exciting part. What's going to happen if we substitute Planck's constant h bar equals to 0 in this equation? We are going to end up with something really interesting. Substituting Planck's constant h bar equal to 0, we are going to end up with this simple equation right here. Now, if we represent this variable s as action, then gradient of the action is just the momentum. In that case, this equation translates to del S by del t plus Hamiltonian equals to 0, which is one of the most famous equation in classical mechanics known as the Hamilton Jacobi equation. So, the universe in which we live is purely quantum mechanical. And classical mechanics, which we use in our day-to-day life, is just a special case when Planck's constant, h bar, is taken to be 0. And the Schrödinger's equation, which we use in quantum mechanics, is just the Hamilton Jacobi equation where Planck's constant is considered. This idea also shows how action, which was previously assumed to be a classical mechanics concept, can be associated with quantum mechanics. Also, this idea leads us to Feynman's path integral formulation of quantum mechanics.